Hello, everybody.
Hello, everyone. This is Dennis Sawyers. He is a lead data scientist at 5 Hour Energy's parent company, Simplify Innovations LLC. Previously, he was a senior cloud solutions architect at Microsoft, where he helped Fortune 100 companies build end to end data and AI platforms using Microsoft Azure. And at Ford Motor Company, where he was a data scientist working with petabyte sized connected vehicle data. He's the author of Automated Machine Learning for Microsoft Azure, is a graduate of University of Michigan and Carnegie Mellon University, and is also fluent in Japanese. With that, Dennis, I will let you take it away.
Thanks. Nice to meet everybody here. Today's presentation is a technical demo on Medallion Architecture for the Walmart API. So, starting off first, what exactly is Medallion Architecture? A lot of you might be familiar with this concept. However, there's a lot of guidance on Medallion Architecture. But if you really look into it, the only thing they really agree on is that there's 3 layers of data. Other than that, you'll get very different instructions as to what to load into bronze, silver, and gold layers. And we're going to go over that today. And we're going to go over it with one of the most popular data sets to use for retail corporations. So here's the agenda. First, we'll define Medallion architecture. Then we'll talk about how to build a bronze layer with Azure Machine Learning Service. And I'll go through the process and a little bit of the code behind that. Next, we'll build the silver layer with Azure Databricks. Next, we'll talk about building gold tables with your business. I have a very small example there, but the process is most important for the gold layer. And then we'll talk about how to orchestrate everything with Azure Data Factory. So to begin, what exactly is Medallion architecture? So this is a very common design pattern used in data engineering. It's been made popular by Databricks. And basically what you're doing is you're processing data in 3 consecutive layers. You have bronze layer, which is usually defined as a dump of all data as is without transformation. You have your silver layer, and usually this is the one where you'll get conflicting guidance on, but the whole point of the silver layer is to make the data more usable and meaningful while still being broad. And last, you have the gold layer. This is the business layer. This is the one that will be used by end users, by data scientists, by data analysts, by whoever is consuming information. And here's a more specific definition. This is how I like to think about Medallion architecture. For the bronze layer, I like to think of it as data as is without any transformation at all. And the main point of the bronze layer is to serve as input for the silver layer. Then with the silver layer, this is where you combine the raw data to make one big tables, and we'll go over that, how to do that with Databricks. And its main point is to serve as input for the gold layer. A lot of the times you'll hear guidance about silver layers for data experts like data scientists or data analysts. I really don't ascribe to that, and once we get to the gold layer, we'll talk about why. And then finally, gold layer. This is the final layer where data is transformed and aggregated for specific business needs, for analytics, also for machine learning and artificial intelligence. Now, what this architecture ends up looking like, and this is how I do this for the Walmart data, is we're going to use Azure Machine Learning Service to build a pipeline that's just a Python pipeline that will ingest the raw data from the Walmart API. That's in the format of Parquet files. That gets stored into ADLS Gen 2, so that's the Azure storage. And Amazon would be similar to S3 buckets. This is where your bronze layer is going to be. Once you have that, you have a single Databricks notebook that is making your entire silver layer, which is also stored in ADLS Gen 2. All the layers are stored in ADLS. Once you make that silver layer, then you can, on a project-by-project basis, start constructing the gold layer for your business. And one important thing to note is that everything here, the AMLS pipeline, the single notebook for making your silver layer, and the many Databricks notebooks for making your gold layer, all of them are scheduled and orchestrated via Azure Data Factory. If you're not familiar with Azure at all, Azure Data Factory is probably Microsoft Azure's best product. It is extremely easy to use. Its main purpose is to orchestrate jobs to schedule them, and it's very good at that. I think it gets a lot of bad. So, yes. No, wait, no slides are appearing? Oh my gosh. Okay. Jeez. Sorry about that, guys. Oh, I had a really, oh man. Okay. All right, guys. I apologize for that. Are they appearing now? Okay, perfect. So first, what exactly is a Medallion architecture? Covering the agenda. First, define the Medallion architecture, build a bronze layer, build a silver table, build a gold table, orchestrate everything with Azure Data Factory. Skipping over that definition of the more general definition of the Medallion architecture to the specific definition. Bronze layer is data as is without any transformation at all. It serves as input for the silver layer. That's going to be Parquet files in this case. So just raw Parquet files. Next, we have the silver layer, which is going to be where raw data is combined and validated in one big tables. We're going to do that with Azure Databricks. That's going to serve as input for the gold layer. The gold layer, you can think about that as the business layer. For the architecture, here's the architectural diagram. We start by ingesting data with an Azure Machine Learning Service pipeline. So this is a reusable artifact that you can schedule, and we'll show you how to schedule that. That pipeline is going to create files that fit into the bronze layer, which is ADLS Gen 2. Databricks is going to suck in those files and turn them into a silver layer. And you'll have two notebooks here. One notebook will be for the first initial load where you're pulling in all the historical data. And then you have the second notebook, which is ingesting daily data. Once you have the silver layer, then you can make many notebooks on a case-by-case basis for your business to store in the gold layer. All of this is being orchestrated with Azure Data Factory pipelines. So once we have that, out of the way, now that we have that out of the way, I'll get right into it. So first, Azure Machine Learning Service. So all Azure Machine Learning Service is, it's kind of a misname because you can use Azure Machine Learning Service to write non-machine learning jobs. And I find it very powerful for developing containerized Python jobs. So in order to get to those Python jobs, I'm going to click Compute. I'm going to navigate to the Jupyter Notebook. It's all in our dev environment here. Walmart Daily Data Ingest. So this single notebook creates the Azure Machine Learning Python, the Azure Machine Learning pipeline that we're going to schedule. And years ago when I worked at Microsoft, I created a bunch of notebooks that do these for different tasks, both machine learning and non-machine learning. So I'll just explain briefly what these pipelines do and why they're so good to use. So first thing it's going to do is you're going to want to connect it to your Azure Machine Learning Service workspace. And this is for the purposes of logging. It does a lot of really awesome auto logging, and I'll show you what that looks like in a little bit. It manages your compute resource. So for this one, I'm using this remote compute. I'm using a really small, cheap compute for this. So just a standard DS3 V2. So this compute only costs 29 cents an hour. So this, and I want to point out, all of this stuff that we're running is really cheap to do. So you can save your company a ton of money just by running your jobs like this, your architecture like this. Next, we're going to create that Docker container and environment, and this is what this does. So these are all the different packages that we're using here, all your different Python packages. It's being saved in this environment object, which I've just called Walmart environment. And then we're creating a Docker container here. It's a CPU-based Docker container. What I really like about Azure Machine Learning Service is all of this gets abstracted pretty easily. It makes creating Docker containers extremely simple. Next is just defining what you want to call your PI files. I have a unit testing PI file, and then I have I have another file for functions that just stores functions, and then the ETL file is just called Walmart ingestion.py. Then each of these little scripts is just writing your file, right? So it's just writing 3 little .py files. I usually have the shared functions.py here just to show people that you can do this more than anything. Same thing with unit testing, to test any function that you created in the first step. Now, what this ETL does, a few different things here. So we're collecting all of our passwords for the Azure storage account. We're also getting our Walmart password as well. That's what this consumer ID is. Connecting to Azure Blob Storage, and we'll show you where this writes out after I demonstrate this notebook a little bit. And really, you need to download a JDK file to create an authentication signature to log into the API. So it's doing, that's what this line of code is doing. Okay. And just getting down a little bit here. This is really the key API that you're calling, this bulk feeds API. Now, Walmart has an extremely well-documented API. So let me just log into it really quick. Okay, APIs and services. All right, so this is kind of the instructions to all of this. And what the bulk feeds is doing is telling you which APIs which data feeds you're subscribed to within the API. And what you see on your left-hand side of the screen here, these are all the different APIs that we call within the script. So getting back to it, there's more stuff with the bulk feeds API, just formatting the data a little bit. And what we're doing here with this code is we're pulling in all of the data from the Walmart APIs. And we're doing that by feed date. So essentially what we're doing is we're checking the latest feed date. And then we're pulling everything that has been created since that here. That's what all these timestamps are for here. And then we're downloading all of these files one by one, and then writing them out, and then updating the status file to include which feeds have been downloaded and when. And that's the whole .py script. And what the rest of this does is it specifies which steps to run. So we have a unit testing script. We have this ETL script. The pipeline first runs the unit test, then it runs the ETL script, and it's called Walmart ingest. And to show you what that looks like here with the logging features, which is one of the things I love so much about Azure Machine Learning Service, you have the log of the job right here. So in this case, it's more about the authentication of the signatures. Here tells you that the status file has been uploaded, cleans up the script. Now, if we ran this at a different time, it would show you which now I ran this at a time when no additional files had been generated by Walmart, but what you would see here is each file that was downloaded within the log. So it's pretty easy to run. Once you do that, you publish the pipeline, and you get an endpoint, this pipeline endpoint, and you can use that to schedule it via Azure Data Factory, which is something we're going to show a little bit lower. The published pipeline is going to be called Walmart_ingest, and then this pipeline endpoint, Walmart ingest pipeline endpoint. Usually I take out the underscores here, so I just forgot to do that when I made this. Now, what does that create? Well, that whole thing that I just showed you creates this layer of data. So this is the data lake, and here's our Walmart section, and we have the bronze, gold, and silver layer. So what you see here is that with Walmart, there are three different types of files. You have your history file. I'll just show you this for sales. And the history file is a one-time thing. It's divided into many parquets. So this is like the last 2 years of a 5-hour sales history from, I think it's like July backwards. And this is just a one-time thing when you get set up with the API. You also get snapshot files. These are dimension tables, if you're familiar with star schemas. These get updated. Some of them get updated every day. Some of them get updated every week. You always want to use the latest version of the dimension tables. They're always backwards compatible with older data, so you don't have to worry about that. So examples of dimension tables are the calendar table, which has all the different Walmart dates versus calendar dates, store dimensions, product dimensions, item attributes, stuff like that. And most importantly, you have your incremental tables. Now, the way we're storing this, let's pick one. Trying to find a good one to show you. Oh, load more. I was looking for store sales too. So every day we're going to be getting a one parquet file with updated information. The way you want to save it on the back end with a bronze layer is within the folder, you're going to want an individual folder for each date. That way, if there are multiple parquet files, they're easy to find. With Walmart, however, most of the time, you're just going to be getting one parquet file a day, from what I can tell. So that's what the bronze layer creates. And once you have all of that, then you want to mosey on over to Databricks. So you can run all of what I just showed you within Databricks. It's just more expensive to do so, so I'd rather not. Once we're here, though, there's two things that you got to do. First, you have to make the initial silver layer, and that is what this very large notebook does. Once you make the silver layer, then you have to set up a what was I going to say? Another job that ingests data incrementally every day. So with this, you're pulling in two different files, right? Or two different types of data. You're pulling in the snapshot data. You're pulling in the historical data. And what this does, I can just start kicking it off. First, this is just listing all of the different Parquet files that are part of the historical data, and it's making a Spark data frames out of all of it. Because this is Spark, this is very fast, so all of the different data frames have already been created, like 60 of them. And then we do the same thing for snapshots. So this is just reading all the snapshot data. First cell was historical data, next one is snapshots. And then once we got that done, then we can start cranking out the silver layer piece by piece. Now, unfortunately, there's no easy way to make the code dynamic here, because each silver layer, is going to require different dimension tables. And what's really cool about Walmart is they have the single best data dictionary and data modeling program that I've ever seen. I've been doing this a long time, and it's really, 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 really good. So this is the API guide. It's telling you the endpoints that you have to hit, and that's what we're doing in the Azure Machine Learning Service pipeline. And it's also telling you about how they tell you to update data. So the data is either going to be it's either going to tell you to delete a row, insert a row, or replace a row. So that's delete, insert, upsert. Upserts to update an existing record. And here's how the table joins to other tables. And this is the information that you're going to want to use to make each of those silver layers. So in this case, you have the main fact table, which is store sales. So there's a historical table for this. There's also an incremental table. That hooks up to item attributes. That hooks up to store dimensions. And you can see very easily here that that's based on store number, Walmart item number. Now, what I like to do too is also identify the main date field in the table, and that's this business date here. And then figure out what that is. It's usually going to be calendar date when it's a business date, and then join it to the calendar as well. When you join it to the calendar as well, that gives you things like which calendar week of the year is it, which Walmart week of the year is it, and yes, they are different. So when you're talking to Walmart, you're always going to want to be using their calendar, but internally, we always use the main calendar date. If you've ever worked at a large corporation, you know that dates are absolutely the worst to deal with, just because companies often have their own internal calendar that they use, and it's inconsistent. They tell you the grain of the data. So when you're doing the upserts and inserts and deletions, you're going to want to use this as a key field. So for the store sales table, it's business date, Walmart item number, store number, service channel. All combination of these 4 fields are unique. That's how you want to think about it. History goes back 2 years. While we're pulling it as Parquet, you also have the option to pull it in as a CSV or ORC file as well. And then they have this really convenient thing to tell you all the different fields in the title, which has the column name, which is this technical name, whether it's an integer, long string, or date, etc. Then this is for Parquet. For CSV, everything's a string, whether it's a primary key or not. So it's really easy to read through and figure out exactly what you're dealing with. There's also the data dictionary. And this is absolutely amazing. I wish every single company had this. Okay, does take a minute to load. But this gives you a description for every single column in the API. So this one right here, a number based on the sequential order of Walmart quarters up to the given date. with examples too. For example, February 2007 would return, this. It's used to calculate a difference between Walmart quarters. It's searchable. So I'm trying to find the search. It's a little bit smaller than what I'm used to here. Can we just look up DC number? Or no? Well, anyways, that's not showing up on my screen, but that's okay. But this makes this API extremely easy to deal with compared to pretty much any other API that I'm using, where there's no data dictionary. There's no good explanation as to what the key fields are, none of that. But, this API is extremely easy to use because of that. So back to the notebook, what we're doing here is we're pulling in that store sales data frame we just created. We're pulling in the dimensions, attributes, calendar. We're identifying how we're going to join everything. So we're joining store. We're joining on store number, Walmart item number, and calendar date. And one of the difficulties you're going to run into while working with Walmart data is that some of the data frames are going to have duplicate column names within them. An example, pretty much everything has this like geocode region field in it, and in order to make everything explicit as to where each field is coming from, created this rename duplicate columns function. And all that does is where there is a duplicate column, it'll append append a store dimension to it, item attribute to it, calendar to it, just to indicate where it's coming from. And then two things here. We just join everything together. So all left joins, joining everything to the fact table. And then doing a data quality check at the end, making sure that that after the join, you still have the same number of rows as you did in the original dimension table. This is so you don't get any accidental Cartesian joins out of it. And we'll get into a little bit later, like why I put this in there as we go down a little bit through these things. So store sales 2, it's the same thing. Omni sales, it's the same thing. You see, there's a lot of different tables here. I'm also creating a weekly calendar from the main calendar. Now, the calendar snapshot table is on a daily level, and what this is making a calendar on the weekly level. And this is because about maybe a quarter of the fact tables are in a weekly grain instead of a daily grain, starting with this UPC sales table here. So we're using the weekly calendar table here instead of the main one. So in a lot of this, like I said, just all the way down, it's pretty much the same thing. Now, once you get lower down, you get into these weird purchase order line tables. And these ones gave us a lot of problems. And I'll show you why really quickly. So one of the things that I don't like about this API is oftentimes you're joining fact tables to fact tables. Not often, well, just in a few of these. So purchase order line and purchase order are both historical and incremental tables. They're both fact tables. And what I figured out eventually is that in the silver layer, it's best if you don't join them here. This is because if you do join purchase order number to purchase order number on just the purchase order table, you do end up getting a Cartesian explosion of records. And I'm not sure if this is intentional or not yet. So this is something that I've worked a little bit with the Walmart team on a feed by feed basis to figure out like what's intentional and what's not. So within the data, that's why we have this whole like count, this count check at the end to make sure that doesn't happen. And then when it does happen, what I do is separate the silver layer into two different tables. And the other reason you need to do this is when you're ingesting incremental data, you will have to update each fact table independently before joining them. So you don't want to do it. You don't want to join two fact tables together and then do that. It doesn't work. So once we have all the tables written, and as you can see, there's quite a lot of them, then I'm just doing a simple count at the end. And you can see that, the number of records varies quite wildly from 38 here to 156 million here. See, I think the biggest one is probably the demand forecast table, which is 156. Order forecast is over 100 million. So it's not like large data, but we have to remember too, 5-Hour Energy is a pretty small company relative to other vendors, right? So we only have one main brand, one main product line. But if you're a company with thousands of product lines, these tables are going to be absolutely gigantic, which is why you want Databricks and Spark. Once we have that here, then we're writing the tables. And this is good. This is good. So I'm glad that this failed here. I didn't mean to do run all earlier. Good. What we're doing here is we're writing the tables back to Unity Catalog. So Unity Catalog, that's keeping track of everything within Databricks. These are all written in Delta Lake format. Just doing overwrites. Once we have that done, we are optimizing the tables with Z order. This makes the queries a lot faster when you do this. Retaining the last 168 hours of data when we do this as well, just so you can do time travel. This is not relevant for the one-time load, but it is relevant to the historical. So I'm going to switch to this, or it's relevant to the incremental updates. So once we have that done, then it's really time to talk about the, not the historical one-time, but the incremental daily digest. So here you're pulling in snapshot. You're pulling in snapshot incremental. That's the important things here. You're reading in all those Delta tables that you just built in the earlier notebook. And you're doing a lot of the same thing. Let me just start running this a little bit here. There we go. All right. All these are read very quickly. And we're storing them all in this, we're storing them all in this dictionary here. All the different data frames in here. So they're all written, they're all assigned. And then what we're doing here is we're filtering, we are filtering to the latest to the latest date. And we're looking for any new Parquet files that have shown up. So item trade has new ones here. It's going down through the list. And then using the new files, it's pretty much doing what we did earlier. Instead of the historical data frames, we're pulling in incremental data frames only. We're still pulling in the dimension tables, the calendar table, and we're making these incremental silver tables to load in. And then once we get to the very end of this, we have the logic here, which is going to decide if you're doing a delete, insert, or update. Now, with the Walmart API, the way that you need to do everything is first perform the delete operations. That's what's going on here. Then you do the insert operations. And lastly, let's see. Yep. Then you do the upsert. Then you do upserts. Yep. Yeah. So it's delete, insert, upsert. I think that's correct. Identify rows to delete. Yep. And we're looking for the I flags. Insert. And then this co-op one, I just overwrite it every time because it's a really tiny table. So once you have all these things done, that creates your silver layer. Going back here, so Walmart silver. Let's go to store sales. A little bit more. So I have this partitioned by year. So we have 2022, 2023, 2024 all stored. And what you're going to see is just the usual, it's just the usual Parquet files. So this hasn't been optimized yet. So once it gets optimized, what you're going to see is all these shrink down drastically to just a couple large files in the hundreds of megabytes to low gigabyte range. Once you run that optimization function on it, I remade a lot of this yesterday for this dev environment to this dev environment. So the optimization job runs a while. Now, once you have all that done, it really comes to just scheduling the incremental stuff, and that's where Azure Data Factory comes in. So Data Factory, really easy to use tool. Here's what this pipeline looks like. I have two of them here. This is a drag and drop tool. It's very easy to use. To schedule a machine learning job, you drop it here. You select the service that you want to connect to, and you're going to pick that pipeline name. So I remember I named this Walmart ingest pipeline endpoint. You have it there, and you're literally good to go just like that. So here we have the ingest data from Walmart API pipeline endpoint set up and running. We also have the Databricks transform data into silver layer thing running. So what this is doing is it's scheduling that Python job with AMLS. It's scheduling the Databricks Spark job with Databricks. In order to select the notebook, extremely easy. Just hit browse, and it takes you right to your folders. You just pick a table to schedule, and you're good to go. This job triggers every day at 8 a.m., at noon, at 4, and at 8 p.m. And that's just because Walmart is inconsistent as to when they provide new data. So you never quite know when in the day you're going to get it. I'm not quite sure why that is. I also have another job that has the first two steps, but then it also runs an optimization job later on. And that all that optimization job does is it runs the optimize function in Databricks and the Z ordering, and vacuums old files. I only run this once a day because it takes a long time to do. So I don't want to waste money running it every single time the job runs. The other really nice thing about Data Factory is it's really easy to set up alerts with the system. I'm not going to go through, it's via this monitoring tab here. I'm not going to go through how to set up alerts, but actually a new alert rule. So basically you're looking for pipeline fail. And then what you can do is you can configure email, SMS, push, and voice notification here. So for the jobs I have in production, if one of these fails, I will get an email message and a text message. For the most important jobs, I have it call up my phone as well. And you get a phone call that says check Azure Data Factory in a robot voice. So that way, it's very easy to know when everything fails on you. There's also a monitoring tab. So because I tried getting this up and running, so we have all these different jobs here. You can see that it succeeded at noon. It succeeded at 4 p.m. And the noon job was longer just because there was a lot of files to process, a lot of new data to process, whereas 4 p.m. probably had nothing or maybe one or two files to process. So that's the discrepancy. Now, once you have the silver, now I want to point out two things here. Up until this point, you really don't actually need to talk to the business. You have all you need to do is follow the instructions that Walmart gives to you via the API. So you could set up that bronze feed and then your silver feed. But then when you're making the gold layer of data, that's when you need to talk to your business. And I'm just going to give you like a horror story of this. So I'm a lead data scientist, but I'm kind of one of those lead data scientists who gets forced into data engineering because we don't have data engineers. And it's been like that at every job that I've worked at so far. So I think it's a pretty common experience for us. So it's funny because even when I talk to data engineers, I know in my head that they should be talking to me more than they are. But when I get the data from them, I just end up, accepting it as is. So, and this is a relatively recent one, working with another company. So I asked one of their data engineers for sales post returns. This is just a data analytics project, like a reporting project. And what he gives me, it's basically a silver table, one of those ones that we just stood up there. Now, the problem with silver tables is, one, they're very wide. So that calendar table from Walmart, that's like a few hundred columns. So when he gave me a silver table of his company's sales data, it's like 300-400 columns. So it was quite a lot. Now, and I specifically asked for sales post returns. Now, I assumed it was sales post returns, but it wasn't. It had sales and returns in there. If you wanted to get sales post returns, you actually had to do a pretty complex query in order to get that. So what ends up happening is that my team builds a 30-page report based on inaccurate sales data because we didn't account for returns. So when you're making the gold layer, the most important thing is to avoid this situation. And this is why I tell people don't give silver layer data, which is essentially just taking the bronze layer, turning it into a big table, or turning it into a star schema. Don't give that to your end users Or if you do, make sure you have a very, very, very long conversation with them explaining what each column in that table does. So when I think about how to build a gold table, when I put on my data engineering hat, I think of things that need to be built to be queried as easily as possible by the end user. So if they're interested in sales data, I think the query should just be some sales. They want to filter it stores to regions, some sales where region equals this, where store equals this. So to this extent, I strongly advise to build each goal table with a specific purpose in mind. And it is okay to have giant goal tables that do answer a ton of business questions. But you need to make sure that your data analyst, your business analyst, your data scientist understands exactly how to answer each question with that data, so they don't end up in a situation where they create reports based on inaccurate data. And when I worked at other bigger companies, Ford Motor Company, for example, this was a huge problem. A data analyst would get a table and not realize that there's a total row in there, and they would end up overstating sales by exactly 100%. That happened a lot. There's a lot of little nuances that you need to figure out as a data engineer, and then communicate that to the goal table, communicate that to your end users. So, and just as a really quick example here, this is a goal table that I made for an economist. Now, this was a one-off project, so I didn't bother. I didn't bother scheduling it. Silver Lake gold right here. Unknown, select resource, attach and run. And all he wanted to do was something very simple, extremely simple. He just wanted to take the Walmart sales data, and he wanted to do a comparison of year over year sales for January through August, just to see how we're doing. So I sat down with them, and I ended up making this notebook for him and gave him the results. We are working to turn this into a broader thing, so he can examine periods, any period that he wants. But the whole point of this, it's really just to show that you need to talk. You absolutely need to talk to the business. So with here, we're just doing a quick record count. We have nearly 11 million records in here. Maximum date is October 3rd. And I ended up making this gold level table from him, from that gigantic sales table, just by selecting a few columns. So, the end result is this final ordered column. It has the business data in it. It has a total sales amount. It has stores by state. It has total sales for the prior year, a total quantity in terms of little energy bottles, and then it also has all that year over year stuff calculated in it. So usually, if the person is data savvy enough, you don't have to create these columns for them. If they're not data savvy at all, then you need to create these calculations for them, just because they won't know how to be able to query it. But the most important thing here is just talking to the business, sitting them down, scheduling a couple, Zoom meetings that last, maybe 30 minutes to an hour, and then figuring out their technical ability, what they want, and how they expect to query the data. Because if you don't do that, you end up with people who misunderstand the data that you're providing them. So that's my little presentation here. I wish I had more time to go, more in depth into everything, but I do want to open up for Q&A and just fire away.
Dennis, awesome. Thank you so much for sharing all that. I know I have a ton of questions. Before that, I will go into chat to see if there's anything in here.
Sure.
Ramona asked, how do you deal with changes in the API?
Oh, that's fantastic. That's a fantastic question. Two things. There's two things. Um, so uh, within the incremental um, yeah, I don't need to show this. I could just explain it. I have two things. One, if new columns are introduced that weren't there previously in the code, I have it backfilling everything else with nulls. That's one way to handle it. Um, when um, when when there's big changes to the API, Walmart lets you know. Do you see these exclamation points here? So this is something that I check once a week. You have release notes, you have change logs, and it tells you that these tables have been altered. And sometimes the alterations are a little hard to handle, most notably when they change the key fields. And what I do, what I do is to make sure that everything keeps running smoothly while I fix it. Okay, because you do need to go in there and fix it. Within this code, it's right here. Okay, so if base name whatever, continue. If base name sales sales tender, continue. Like, these are new things that were recently put in, so I need to add in these new APIs. Ecom return, sales tender, and stock transfer did not exist when I made it. And there was a change to hourly store inventory as well that I need to account for. So basically what I do is I skip it to make sure that the incremental keeps running. Then I dig into it, and then I'll do things like fix the key fields, or if necessary, rerun the history if I need to. One of the nice things about segmenting the data out like that with your bronze layer is you can always remake everything just from the bronze layer. So you can delete the gold tables, you can delete the silver tables, you can, and then from the bronze layer, you can remake it with new logic. That's a great question. And it does come up, but Walmart's pretty good at not making changes that break things too much. So it's a great question.
That's funny because my company is a Microsoft D365 shop,
Yeah.
and D365 just changes everything without telling anyone, and it's always a mess.
Walmart doesn't do that. It actually tells you. But like,
Yeah,
it has this release notes section, and it has this change log section, and it tells you like weeks and months in advance that this stuff is coming. So
yeah.
it's
No,
like,
Dynamics 365 will literally just sneak a table in there
yeah.
and won't change you, and then decommission like the previous table.
Oh,
And you're like, oh, like why did my entire pipeline break? It's oh, better go check to see if Microsoft changed anything.
yeah, that's yeah, that won't happen with this, just because, like I said, this release note stuff, it's really great. I'm really impressed with them. So
John asked, where
yeah.
did you learn Databricks and Azure Data Factory? Could you recommend an author or course to learn these technologies?
Yeah, actually. So I learned Azure Data Factory and Azure Databricks on the job while working in Microsoft, but I did it in such a way that as long as you have access to an Azure account, you can learn it too. Just go to the documentation and start reading it. So read the documentation for Azure Data Factory, read the documentation for Azure Databricks. There's a lot of free Microsoft like Learn courses as well. I don't have a handy link on me, but uh, if you just work through the tutorials yourself, you're going to learn all this stuff. It took me about, I'd say it took me about 8 weeks to learn Azure Machine Learning Service to the point where I could write pipelines. It took me about maybe 4 weeks before I got really good at Azure Data Factory. And Databricks, the hardest part is like learning the Spark language. But if you know Spark, then learning Databricks is something that probably will take you another, like, I would say, like, 1 to 2 months. So work through that Azure documentation, work through the Databricks documentation, go to the Microsoft free learning sites. Some people work better with books. Pact, P-A-C-K-T, does have a lot of good books, both on Data Factory and on Databricks. So if you work through the exercises in those books too, it's a good learning resource.
Awesome. Yeah, and same for me. The Microsoft learning resources have been great. It's like a mini game that you play through it, that you like earn experience as you kind of
Yes.
go through the courses and stuff. So it's kind of fun, helps gamify things.
Yeah. And it's yeah, there's nothing like just like building it.
Yeah.
Anything else, or should I move on to final thoughts?
No other questions. There's a couple comments in there for you in chat. So, but other than that, I think you move on to final thoughts.
Okay, so final thoughts. So every Medallion architecture is going to be a little bit different. Everyone has their own take on this, and everything's going to be a little bit different based on the API you're using. One of the things that I really like about the Walmart API is it's extremely well defined. So you're getting these Parquet files day by day. So you know immediately, okay, that's the bronze layer. We're just going to save these Parquet files as is. And next, we can make the silver layer because they give instructions on how to build the silver layer within their documentation, which is great. There's no, you know exactly how everything joins. There's no mystery. It's just these little diagrams. I'm trying to find one. Where is it? Where's the diagram at? Right here. It's just this diagram. You just follow the diagram, follow the key fields, and you're safe. You're good. And also too here, if you're building things out like this, the silver layer requires deep understanding of the data, but you don't have to understand the business at all. You really just need to understand the data model behind it. So, and then you get to the gold layer. Now, the gold layer is where you really have to understand your business. And when building out these tables, have extensive interviews with the business to ensure that everybody involved understands the data, the business, and how to connect the two. Or you'll end up with 30 pages of reporting, based on inaccurate data because of misunderstandings. So as long as you follow that, this is a really powerful architecture pattern to follow, not just with Walmart data, but with anything else as well. And it's a great way, I want to say, to really up your data engineering skills of really understanding this and having a few different projects where you're using one of these, I want to say, more popular APIs to put it into that bronze layer, silver layer, and gold layer. So thank you guys very much. I was really happy to be here.
Awesome. Thank you, Dennis. We appreciate you having here, and everyone in chat, thank you for joining.
Thanks.
Take care.
You too. Bye-bye.